This is going to be a demonstration of thermal expansion. That is the type of expansion that happens when you heat things up. A common example of that is people say to run your spaghetti jar's lid underneath hot water to help you open it, because the metal will expand faster than the glass on the jar. I don't recommend that because it makes your spaghetti jar really wet and slippery, and then you drop the spaghetti jar and it cracks and you've got broken glass to deal with. But for this demonstration, what we're going to be doing is we're going to take this metal ball and this metal ring, and we're going to show that if you heat up the ball, it will actually expand. So right now, the metal ball is the same size as the metal ring, and it fits through just barely. But if we heat that metal ball up in this meeker burner, heating it up will cause it to expand. And as it expands, it will get to a point where it no longer fits through the metal hoop. Because it's actually expanded, it's larger now than the opening of the hoop until it cools off and it can fit back through. So that thermal expansion happens with everything. If I heat this up, it gets to a point where it's warmed up enough that it expands and is larger than the opening of our hoop. And so it can either just barely fit through or it gets kind of stuck. And this happens with basically everything. Like the spaghetti jar that you're told to run under hot water, because when you heat up the metal lid, it will expand and actually get looser than the glass jar because the metal expands faster than the glass. And this is also another demonstration of linear expansion, thermal expansion. This is a bimetallic strip. It looks kind of wavy because it's starting to get old and it's bent back and forth by people. But what this is it's a strip made up of two different types of metal. Every different type of metal has a different linear expansion coefficient, which is a fancy way of saying different metals expand at different rates. If you increase one by 10 degrees Celsius, it might expand by 1 millimeter, and another one might only expand by 0.5 millimeter. But with this strip, since it's two different metals and we've fused those metals together, when I heat it up, what we're going to see is it actually starts to bend. And I've shown this demonstration to people before, and they look at this and they see it just bending, and they don't think that it has anything to do with thermal expansion. They think, well, it just bent because it's melting. You're somehow melting the metal in that really hot flame. But that's actually not what's happening. This metallic strip, the bimetallic strip, has the two metals fused together, and when one of them expands more than the other, it will actually cause it to bend. Because one side of the strip is getting longer than the other side, the only way for them to stay fused together is for the actual strip to bend. And this is returning as it cools down, it gets closer and closer to being straight. Now, once again, some people think that I just heat it up and it bends down because gravity's pulling on it and it's getting warm and malleable. But if I hold this the other way and I heat it up now, it actually curls up. This isn't just gravity pulling down on it. What's happening is that one side of the strip is expanding more than the other side, and the bimetallic strip actually starts to bend. Because one side is expanding more than the other, the strip bends on itself. This used to be really, really important in your homes because bimetallic strips were found inside of the old thermostats that controlled whether your heat or air conditioning would turn on. And if you looked inside of one, you'd see this piece of metal that was coiled around probably about a dozen times. And what that would do is when the temperature changed, the bimetallic strip would actually bend. And so inside the thermostat, if it bends more, it tightens the coils. And if it bends less, it would loosen the coils, and it would actually move the end of the strip up and down. And that would be used to complete the circuit or to break the circuit and either turn the furnace or the air conditioning unit on and off. In modern thermostats, they don't use bimetallic strips anymore because the bimetallic strips actually take too long to bend and coil. And so what they've changed to is they have two metal discs inside of a thermostat, and inside will be a gas. And when that gas expands, when it heats up, it expands, and it actually pushes those metal plates further apart, and the inner plate will either break or complete the circuit, depending on whether it's being pushed in or pulled out. Yeah. So these are both examples of linear thermal expansion, where when you heat a solid up, it expands. And if you have two solids fused together, then it'll actually cause them to bend.